Welcome back, students. Myself Saravanan, Assistant Professor, Department of Information Technology. So today we are going to see about hashing technique in data structure, unit number 5. So before getting into hashing technique, we have to know about some of the drawbacks in linear search, binary search tree, which we learned in the last session. So here in linear search, it's the total complexity is order of n while searching the array elements. In binary search, it takes one order of log n for searching the elements in a shorter array, and also in a binary search tree, the complexity will be order of log n. So when compared to these techniques, these are the drawbacks when compared to hashing, because hashing techniques, it will search very faster, much faster when compared to these searching techniques, right? Next. You can see the main drawback of these techniques is, as the number of elements increases, the time taken to perform the search also increases, right? And this becomes very problematic, right, when compared to the last three techniques. But in hashing, this is a very faster, it can search the element at very speedy, right? Next. So hashing technique, nothing but it needs a hash table. How it's a hash table is nothing but it's a data structure which stores the data in an associative manner. In a hash table, the data is stored in an array format where each data value has its own unique index value, right? Accessing the data became very fast in hashing technique when compared to the previous techniques, right? Insertion and search operations are very fast irrespective of the size here, right? Next. So hashing. So it's a technique which converts a range of key values into index value. You can see here in the example given below. These are the set of key values. After applying the hash function, you can see here it is stored in the values will be stored based upon the index value. You can see here the index value is 0, the value 1 will be stored there. Based upon the index value, the values will be stored. So we can access the values by giving the index value. So it can easily search an element in a large number of sequence of elements, right? Okay, next. So another example showing how the hash function works here. So also when we give a certain of key values means the hash function will be applied there, and the hash value will be generated based upon the index value. The values will be stored there, right? Next. So how the hash function will works? Hash function takes the data item as an input and returns a small integer values as an output, as we seen in the last slide. The smaller integer value is called as a hash value. Hash value of the data item is then used as an index for storing into the hash table. Next. So these are the different types of hash functions: mid-square hash function, division hash function, and folding hash functions. In mid-square hash function, in this method, firstly the key is squared and then the mid part of the result taken as the index value. You can see here the values here is 3101 and the size of the table will be 1000. We have to square this thing. You can see here 3101 will be squared and you will get 9616201. The mid value will be 162, the mid 3 digits. It will be an index value, right? That the values will be stored. Next. This is a division method. I will directly look into the example. You can see here the records 52, 68, 99 and 84 to be stored in a hash table of size 10, right? So here the formula for hashing is, you can see a record model of table size. And then 52 is the actual record, model of 10 is nothing but the size of a table. We will get a remainder of 2. The 2 will be the index here, the 52 will be stored in that particular index value. So like that the remaining data will be stored here. This is how the division method will be worked. Next. So digit folding method so also we can come directly to the example here. You can see here the record value of 1, 2, 4, 6, 5, 5 and 1, 2 is there. So by applying the division method, we have to split the numbers. You can see here 1, 2, 4 is one part and 6, 5, 5 will be on one part and 1, 2 will be on another part. So like this it will be added and you will get values there, that will be an index value. Like that the values will be stored here. Okay. So this is how the hash table will be formulated in 3 different techniques, right? Next. So what are the properties of hash function? You can see here it is efficiently computable and then minimize the number of collision occurs and it distributes the key uniformly over the table. So will not find any collision, right? And also it will be very comfortable while storing the data and while accessing the data also. Okay, next. So, the example, students kindly note this example, you will do in your homework as a homework, right. Next. So, this is an example, I will explain you once again. You can see here the keys are given here, you have to apply the hash function, you will generate, it will give an index value where we will store the particular values there, right. Next. The example, next. So, this is how the you have to frame that structure, okay. It is using the structure definition, there are two values will be stored here, data and key, okay. This is an example. Next. So, we will directly move on to the collision techniques. Next. We will see the characteristics once again. The hash functions will generate different hash values for a similar string. The hash function is easy to understand and simple to compute, and hash function should produce the keys which will get distributed and uniformly over an array, right. Next. So, what are the advantages? So, unlike other searching techniques, hashing is extremely efficient, and the time taken by it perform the search does not depend upon the total number of elements, right. Its complexity will be order of 1, which it will be very higher when compared to the other techniques, right. Next. So, load factor is already seen. Next. It's a problem, kindly note it down, you can do it as a homework. Next. Collusion. Even though here the collision occurs here, the collision have been, you can see next, right. In collision estimation technique, if suppose value stored in same index part, that means the collision occurs there. So, how to overcome the collision here? It comes under two techniques here, separate chaining and open addressing hash table. Using these techniques, we can able to resolve the collision problem, right. So, we will see this topic in the next class, okay. Thank you.